This is lesson 9.1, which is all about parabolas. Our essential question is, what are the geometric properties of a parabola and how do they relate to algebraic representations of a parabola? So this chapter is starting to talk about conic sections. So a conic section is a curve that's formed by the intersection of a plane and a double right cone. So you can see in the illustration here, there are 4 different kinds of conic sections. There's the parabola, the circle, the ellipse, and the hyperbola. So it all depends on how the plane intersects the double cone. So a parabola, we've talked about parabolas before when we talked about quadratic functions, but this is a little bit different because we're talking about parabolas that can open up or down and also ones that can open left or right. So what we're focusing on here is parabolas that have a vertex at 0, 0, and the 2 key pieces of information that we're going to have for our parabolas are a focus, which is going to be a point that is inside of the parabola, so you can see right there, and then the directrix, which is going to be a dotted line that falls on the opposite side, opens the opposite way of the, it's in the opposite direction of the way that the parabola opens. So the distance from the focus to the parabola, or from the directrix to the parabola, is going to be c. And if our parabola opens up or right, that c is going to be positive, and if it opens down or left, it's going to be negative. And then we're going to use these formulas right here to represent, depending on if our parabola is an up and down or a left and right opening parabola. Okay, so our first example says, how would you write an equation of a parabola with a focus of 0, 2 and a directrix of y equals -2? And then we're using the definition of a parabola and to write the simplified equation. So the first thing I would always do if I'm given information like this is I would sketch a little picture for myself. So 0, 2, that's going to be my focus right there. And y equals -2 means I'm going to have a directrix right there. So what that tells me is that my vertex of the parabola is halfway between those 2 points at 0, 0. And it tells me that my parabola is going to open up because the focus is always going to sit inside the parabola. So because it opens up, I know it's going to be y equals, and then the equation is 1 over 4c. Well, c in this case is going to be +2 because that is the distance from my vertex to my focus, and it opens up, so c is positive. So it's going to be 1 over 4 times 2, which is 8x squared. So that will be my equation. For part B, it says, what is the equation of a parabola with a focus at 4, 0? So 1, 2, 3, 4, 0. There's my focus. And then a directrix at x equals -4. So there's my directrix. This tells me that my parabola is going to open to the right. And so c is still going to be positive because it opens to the right. But this time c is 4. And because it's opening to the right, I know it's going to be x equals 1 over 4 times 4 would be 16 y squared. So that would be my equation for that parabola. So the thing that we need to understand is that the focal length of a parabola, the absolute value of c, is the distance between the focus and the vertex. And that distance from the focus to the vertex is going to be the same from the vertex to the directrix. And this illustration right here actually shows that you're always going to have an equal distance from the focus to your parabola will be the same as your parabola to the directrix. So those 2 dashed lines right there are showing that those distances are always going to remain equal. So you can see these 2 illustrations show if your focus is closer to your vertex, that's going to make a narrower parabola. And if your focus is further away, that's going to cause your parabola to be a little bit wider. Okay, So the next example, what's the equation of the parabola? So again, I might sketch a little picture here. So a parabola with a vertex at 0, 0, and my focus is at 0, negative 0.5. So that means 0, negative 0.5 is going to sit right there at the halfway point. And that tells me automatically that my parabola opens down. And so my C value is negative 0.5. So if I write that equation, I know it's going to be y equals, because it opens down, and it's going to be 1 over 4 times my C value. So 4 times a half is going to be 2, and it's negative, so we know this is going to be negative 1/2 x squared. Okay, and then the next one, a parabola with a vertex at 0, 0. So again, our vertex is at 0, 0, and a directrix at x equals 5. So 1, 2, 3, 4, 5. So this one tells me that my parabola is going to open to the left. And so my C value, the distance has to be the same. So C value is going to be negative 5, because we're opening to the left. And so this one's going to be x equals 1 over 4 times negative 5, so it'd be negative 20, and then y squared. Okay. In our last example, we're going to complete the square to find the focus in the directrix. So we're given an equation, and we want to put it into a standard form. So you can see over here we have, this should look familiar, y equals a times x minus h squared plus k. And then the new part we're adding is x equals a times y minus h squared plus k. So what I notice on this when I'm looking at the equation is I notice that the y is squared. So that tells me that this is going to be the formula that we're going to end up putting something into. So the first step that I do is I look for which variable is squared, and then I'm going to move everything over to the other side. So that's going to make this negative x minus 14 equals y squared minus 8y. And so why I'm doing this is because it actually sets me up to complete the square. So we're thinking about what number can we add to this side that is going to make this a perfect square trinomial. And I need to keep my equation balanced, so I'm going to add whatever I add to the right, I'm going to add to the left. So to get this number right here, we're going to take half of the b term, so half of negative 8 would be negative 4, and we're going to square it. And so that gives us 16. So I'm going to add 16 to both sides of the equation to keep it balanced. So that gives me negative x plus 2 equals y squared minus 8y plus 16. So now this, what we just created, is a perfect square trinomial. So it factors into y minus 4, or y minus 4 squared. And then I can move the plus 2 over to the other side. So I have negative x, I can subtract the 2, so I get minus 2. And finally, my last step, I can divide everything by negative 1. So that gives me x equals negative y minus 4 squared plus 2. And that would be my equation in standard form.